in clocks, the concept of time and distance is very commonly used. Though prima facie, it doesn't seem that how can we connect time and distance with clocks. But if you just think of it as a circular track, which is basically what a clock is, a circular track, and two people, minute hand and hour hand, running across the circular track. If we try to think of clocks as something like this, then I am sure we can understand how we can use time, speed and distance here. Alright. Now, this is my circular track in the form of a clock. Now we also know that one circle in terms of degrees is 360 degree, right? Why we talk in terms of degrees? Because we have to measure the distance. Normally when we take a park or any kind of circular track, we measure it in meters or kilometers. But in clocks, it being very small, obviously we cannot use those kind of distance denomination, meter and kilometer or miles. So in clocks, the commonly used denomination for measuring the distance is degrees. Alright, we measure the distance in terms of degrees, and it's very convenient also because we know one circle is 360 degree. Alright, but the way we know clocks is in terms of minutes and hours. So how do we connect these two concepts then? It's very simple. Now we know when the minute hand moves one whole circle, it is equal to 1 hour. Right? When minute hand moves one whole circle, it is equal to 1 hour, which is equal to 60 minutes. So because 1 hour is equal to 60 minutes, which is equal to one circle, which is equal to 360 degrees. So 60 minutes is equal to 360 degrees, which means 1 minute is equal to 6 degrees. So if the minute hand moves by 1 minute, the way we measure distance, we'll say it has moved by 6 degrees. Right? Which also brings us to the next concept, that there are gaps between the numbers which are given. How many gaps are there? There are 12 such gaps. Now these gaps together constitute the circle, they constitute 60 minutes, which means each gap, because the total circle is equal to 360 degree, so each gap, each of these 12 gaps will be equal to 360 by 12, 30 degrees. So this movement of 5 minutes is equal to 30 degrees, right? Now let's get our two runners, the minute hand and the hour hand. Let's see how they conduct themselves in this circle, on this circular track. Now we know the minute hand is obviously the faster guy, the hour hand is the slower guy, right? Therefore, we can say that the distance travelled in 1 hour, one whole circle, is how we try to understand the whole concept. Distance travelled in 1 hour, one whole circle, by minute hand. Minute hand in 1 hour completes the whole circle. The minute hand goes around the circle in 1 hour, so it completes 60 minutes. 60 minutes is equal to 360 degrees. Hour hand in 1 hour, remember, hour hand, how does the hour hand move? Say it's 12 o'clock. If it is 12 o'clock, which means both the hours, both the hands are pointing towards 12, right? Now at 1 o'clock, the hour hand will point towards 1, whereas the minute hand will complete the whole circle and come here. So our hand moves only by 30 degree, 5 minutes, right, in 1 hour. So distance travelled by our hand in 1 hour is 5 minutes, which is equal to 30 degree. So therefore the speed of minute hand is equal to 360 by 60, 6 degree per minute. Speed of hour hand is equal to 30 degree by 60, half degree per minute. This is the most important concept. If you understand this, then most of the questions can be very easily solved. So summarize the whole thing. It's a circular track, its length is 360 degrees. Speed of the faster runner is 6 degree per minute. Speed of the slower runner is half degree per minute. Right? Now we will come to some simple questions and understand how to go about this. Right? Let's take an example. Say it's 4 o'clock. So from 4 o'clock, right, 4 o'clock, we try to find what will be the angle. When we say angle, the answer to angle will be in degrees. So don't get confused by the language. When they say what will be the angle, they are basically asking what will be the distance between the two runners, wherever they are. What is the distance between the two runners? In simple time, speed and distance concept. So what is the distance between the two runners at a certain particular time? Okay. Now let's see how we go about it. So this is at 4 o'clock, which means the faster runner, the minute hand, is at 12 o'clock. The slower runner, the hour hand, is at 4 o'clock. Now, what will be the distance between them, say at 4:10, 10 minutes past 4 o'clock. Now, when they are at 4 and 12 respectively, then what is the distance between them? Right? The distance between them is 20 minutes. Right? 1 minute is equal to 6 degree. So the distance between them is 120 degree. Angle, distance, degree, meters. That is how we have to look at the whole concept. Okay? So the distance between them is 120 degree at 4 o'clock. So what will be the distance between them at 4:10? At 4:10, 10 minutes past 4 o'clock. Let's understand this. Let's first understand this by diagram. So at 4 o'clock, this was the situation at 4 o'clock. Right? So this was the distance between them. What is the distance now? Minute hand has travelled this distance, hour hand has travelled this distance. Now if you try and understand this, the original distance, minute hand is covering the distance, minute hand is chasing the hour hand guy, right? Minute hand is going after the hour hand guy. So he has covered this distance and hour hand is trying to run away from minute hand. So he has covered this distance. Therefore, just think of it very logically, common sense, no concept, no maths required. The original distance, the faster guy is obviously chasing, the slower guy is running away from him. So the faster guy covers some distance, the slower guy also covers some distance in the interim time period. Just think of it, what will be the distance finally between them? Original distance minus the distance covered by the slower, faster guy, plus the distance covered by the slower guy, the chaser and the chased, right? Therefore, original distance, right, is 120. What is the distance covered by the faster guy, the minute hand, the chaser guy, the guy who is following? It will be 10 minutes into 6, 60 degrees. What is the distance covered by the slower guy, the hour hand guy? 10 minutes into half degree per minute. Remember the speed of the hour guy, huh? We did that. Half degree per minute, which is 5. So minute hand has covered 60 degrees, hour hand has covered 5 degrees. Original distance was 120. So 120 minus 60 plus 5, which is what I have written in terms of equation. 120 minus 60 minus minus plus 5, which is equal to 64. Okay, so this is a simple way of answering such questions. So let's understand what have we done here. We took, when we are asked questions about say 4:10, our starting point is 4 o'clock. Always remember, say 6:55, the starting point will be 6 o'clock. 7:33, the starting point is 7 o'clock, right? So our starting point is always the previous hour time. We find what will be the distance at the previous hour time, then we find the distance covered by the minute hand, and then we find the distance covered by the hour hand, and therefore by logic you can find it. But there may be a case that original time may be 4 o'clock, but hour hand may overtake the minute hand, may overtake the hour hand and go beyond it, right? Then what happens? Let's try and understand. Say at 4:40, if we try to find the angle between them, angle is distance, angle between them at 4:40. So this is a very poor representation of a clock, but we are learning maths here, not drawing, so I'm sure you'll appreciate and also sympathize. So this is at 4:40, okay? So this is 4 o'clock, the original situation, the hour guy, the slower guy, the chased at 4 and the faster guy at 12. Now what does the faster guy do? He runs all the way to 8. What does the slower guy do? Obviously he is the slower guy, so he will run less. So he just moves a little bit between 4 and 5. And now what is the distance? Okay, that is what they are asking. What is the distance now? If you think of it, the diagram is a little clumsy, but pay attention, I am sure you will understand this. This is 4 o'clock. The minute guy has gone all the way here. The hour guy has moved a little bit. So this is the angle that we want, right? Can I say this angle is same as the distance covered by the minute hand minus the original distance minus the distance covered by the hour hand? Distance covered by the minute hand minus the original distance minus the distance covered by the hour hand, right? And this is what we have done here. Because 40 minutes, speed of minute hand is 6 degree per minute. So distance covered by minute hand, 6 into 40, 240. Speed of hour hand, half degree per minute. So distance covered by hour hand, half into 40, 20. Original distance at 4 o'clock, 120, right? Therefore, distance of minute hand, 240. Distance of hour hand, 20. Distance at 4:40, the question will be distance covered by the minute hand, 240, minus distance covered by the hour hand, minus the original distance. So 240 minus 20 minus 120, the answer is 100 degrees. Okay. So basically we did two situations, right? In every situation, we tried to find the distance between minute hand and hour hand. What was the difference in the two situations? In the first situation, the minute hand is behind hour hand in the clockwise direction. In the second situation, minute hand is ahead of hour hand in the clockwise situation. Now let's just summarize the whole thing. Angle is nothing but distance. How do we measure distance in clocks? Degrees. It's a substitute for meter, mile, kilometer, whatever, right? Who are the two runners? Hour hand, minute hand. Who is the faster one? Minute hand. Who is the slower one? Hour hand. What is the speed of the faster one? 6 degrees per minute. What is the speed of the slower one? Half degree per minute. So what will be their relative speed? You know, when because they are going in the same direction. Remember, both of them are moving in the clockwise direction. So the relative speed will be the difference of the speed. 6 minus half, which is 5.5 degree per minute. Okay. And two different situations. Once when minute hand is chasing but has not yet reached the hour hand. Another one when minute hand is chasing but he has overtaken the hour hand. In each situation, we start from the previous hour timing. So if we are asked, say 9:21, we will start at 9 o'clock. Okay. For example, let's do this 9:21 verbally. At 9 o'clock, the distance between them will be 270 degree. That is easy to find also. You can draw the diagram and understand. 9. Each hour gap, 5 minutes is 30. So 30 into 9, 270. Okay. 9 o'clock. Now when I say 9:31, try to visualize 9:31. Will the minute hand overtake the hour hand at 9:31? 9:31 won't overtake. Minute hand will remain behind hour hand at 9:31. Right? So we will use the first concept. 9:31. So original was 270. So minute hand is chasing the hour hand but he has not overtaken. So he is somewhere behind the hour hand. So original distance minus the distance covered by the minute hand plus the distance covered by the hour hand. Okay. In 31 minutes, the relative speed is 5.5. So the distance covered by minute hand and hour hand respectively will be 31 into 5.5, which comes to 15.5. So somewhere around 170.5. Okay. So 170.5 is the respective distance covered by them, the difference of the distance. Original distance was 270. So the distance now is 270 minus 170.5, which is equal to 99.5. Okay. Now what I have done is that once you understand the concept, I have compressed all of this into simple formula. We don't need to rediscover the wheel every single time. We have understood it. If there is a complicated question, we can draw the diagram and use our concept knowledge. If it's a simple question, we should do it very fast in 15-20 seconds. So there we must have a ready-made formula. So I have made a formula. Pay attention to this now. The formula goes like this. This is the formula. New means the new angle, the angle that they are asking us. Old is the angle at our hand. 4:33, the angle at 4 o'clock. 7:11, angle at 7 o'clock. 11:15, angle at 11 o'clock. Right? Old angle refers to that angle. Minutes refer to the number of minutes after the old angle. Say if the question is about 3:23, then minutes is 23. Okay? Divided by 11 by 2, which is a fixed number. Now you see the sign here is not plus or minus, it's plus or, it's basically it can be plus or minus. In fact, you can have two answers also, from plus also, minus also. So there can be two answers also. When do we use these signs? We use sign plus when old plus new is less than equal to 330 degree. When do we use minus? When old is greater than new. Okay, obviously we'll use minus when old is greater than new. Okay. अरे यार लास्ट वाला पार्ट तो गड़बड़ हो गया.